Moving on to 8.4.1, ionization constant of water and calculation of pH and pOH in aqueous medium using given Kw values. Water is a unique compound due to its ability to accept or donate proton under different environments. It has been mentioned earlier that water acts as a Bronsted acid in the presence of ammonia and a Bronsted base in the presence of hydrochloric acid. In fact, water itself undergoes ionization to a small extent as shown in the following equation. H2O plus H2O gives us hydronium ion plus hydroxide ion, and the reaction is regarded as auto-ionization of water. And here a molecule of water which is acting as an acid donates a proton to another molecule of water acting as a base, and two species of hydronium ion and hydroxide ion are formed. In this equation there are two acid-base conjugate pairs, and the first one is water hydroxide ion acid conjugate base, and the second water hydronium ion base conjugate acid. In fact, there is an equilibrium between water molecules on the left hand side of the equation and the hydronium ion hydroxide on the right side of the equation. The equilibrium constant for this K for this equilibrium can be expressed by the following equation: K is equal to H3O OH minus upon H2O square. In this equation, H3O and OH and H2O are the concentration of hydronium ion hydroxide and water at equilibrium stage. And since water is a solvent, the concentration of water is large excess, and therefore it remains constant. And the above equation may be written as KH2O square is equals to H3O plus OH minus, and the term KH2O square is the product of two constants and is KH2O2 is equal to Kw H3O plus OH minus, and Kw is termed as the ion product of constant of water. And since H3O plus is the concentration of hydrated protons at equilibrium, the equation corresponds to Kw is equals to H plus OH minus, and in pure water at 25 degrees Celsius concentration H plus 1 OH minus are equal and found to be 1 into exponent minus 7 moles each, and thus Kw is equals to 1 exponent minus 7 into 1 exponent minus 7 is equal to 1 exponent minus 14. And it has been noted that whether in pure water or in solution of dissolved species, the following relationship always holds as Kw is equal to H plus OH minus, which is 1 exponent minus 14, where H positive is equal to OH minus ions, and the aqueous solution is found to be neutral, neither acidic nor basic. H positive greater would be acidic solution, OH would be greater, so basic solution. It is noted that because Kw is an equilibrium constant, is temperature dependent, thus at 40 degrees Celsius Kw is equal to 3.8 exponent minus 14, and which corresponds to H plus 1 is equal to 1.9 exponent minus 7 and 1.9 minus 7 of OH minus. And since the concentration of H positive and OH negative are usually very small numbers and inconvenient to work with, there is a more practical way to measure called the pH was proposed and defined as pH is equal to minus log H positive, which means that pH of a solution is given by the negative logarithm of H positive concentration mole per dm cube. However, it must be kept in mind that pH, being a logarithmic value, does not have any units. pH concept implies that at 25 degrees Celsius, different types of solution will show the following behaviors: acidic solution, basic solution, neutral solution. A scale of analogous to the pH can be devised using the negative logarithm of the H positive concentration.